Okay, class 2 alpha, can you hear me? Can you hear me?
Yes, teacher.
Okay, good. And then my presentation, make sure you can also see my presentation. Okay, so can we start now? Yeah, everyone is here? Can we start now? Okay, make sure you can hear my voice, and then also can see my presentation, right? Okay. Okay, the next topic for today, electrostatic charges. Okay, yesterday we already learned about the type of energy, and then the meaning of energy. All right, and then what else we learned yesterday? Okay, and then the SI unit of energy. That is joule. All right, we learned that yesterday. So the example, electricity, meaning that electric is one of the type of energy in the earth, in the world. Okay. The other type of energy is the sun, geothermal, water, biomass, fossil fuel, radioactive, wave, and wind. I already covered that yesterday. And then make sure you also remember the type of energy. There are 9 type of energy. Okay, 9 type of energy that you need to remember. All right, available in the world. Yeah, 9 type of energy. Okay, today we're going to learn the basic of electricity. This is the basic of electricity first. Before we go further, you need to understand what is the meaning of electrostatic charges. Okay, electrostatic charges, right? Okay, electro mean electric. Electro is electric, and then static mean it does not move. Okay, it's stationary. Static meaning that the charges of electric that is not moving. We call it electrostatic charges. Okay, you just remember charges here is the charge. For example, from the word charge. Okay, easier for you to remember your handphone, for example. If you want to, if your battery out of use, maybe if your battery nearly finished, you need to what? You need to plug in the power, and then you need to charge it, right? Okay, so meaning that it need to be what we call charge. The battery, after it has been used for some time, it will need to be charged. Okay, so it is not very different with electrostatic charges, right? Meaning that it will replenish. Okay, meaning that the battery need to be charged. okay, the charges need to be what we call the electric charge need to enter the battery. Then maybe after 1 or 2 hours, the battery already has the charges inside. Then it can be used on your smartphone or on your phone, okay, for maybe about the whole day, 24 hours. Okay, you just remember the word charges here, right? Okay, after this, we go through what is the charges actually, right? Okay, static charges are known as electrostatic charges. Electric mean moving charges. Okay, electricity, for example, the electricity on your phone, on the cable, on your home, if you look at the cable, the wire, wire di rumah itu kan, meaning that inside the wire we have what? Class. Dalam wire ni ada apa kamu rasa? If I show here, the electrical cable, example the picture here, electrical cable here. For example, this one. This is example of cable, right? So inside the cable we have what? What you can see here? Inside the cable we have what is the substance or the material inside the cable, electric cable here actually?
Copper.
Yeah, we have copper, right? Very good. Thank you very much. We have copper. Copper is what? Good electric conductor or insulator? You still remember Form 1? We already learned it in Form 1. Copper. Good what? Class? Insulator or conductor of electric? This one. This one, yes. At the middle here, this is copper. CO, usually made from copper. Usually made from copper. And then outside here, later on, outside later on. Okay, copper is type of what? A type of metal or non-metal? Copper is metal or non-metal? Yes, it is a type of metal. And then one characteristic of metal is it a conductor or electrical? Is it a conductor or insulator of electric?
Conduct.
Yes, it is electric conductor. Okay, conductor, meaning that electric can flow through it. Electric can flow. If you look at the word flow maknanya dalam bahasa Melayu dia mengalir. It's just like a water, but you cannot see the water. Okay, for example, you cannot see the if the water inside the pipe, you can see the water flowing, right? If you have the pipe, the rubber pipe, for example. But inside the electrical, what are the things that moving or flowing inside the copper? Anybody can guess? You cannot see the electric actually, right? You cannot see it. But what actually flow inside the copper? The what? Anybody? Just give me any answer. What is flowing inside the electricity? You just remember, the water, the electricity is moving, flowing like water. Dia macam ada air di dalam. But you cannot see the electric lah as you see in water. Okay, because the things, okay, actually the things, the electric that flowing inside the copper is that we call charges. Okay, the charge of electric is flowing or moving inside the copper. That's why we call it electricity. Okay, electricity, right? Electrostatic, meaning that the charges is moving or not moving. Go back to the textbook. Electrostatic charges meaning that it's move or not moving. Yeah?
Not moving.
Not moving. Yes, electrostatic meaning that the charges is not moving, but there is an electric. There is an what we call electrical energy. There is an electrical energy, but the charges is not moving. Okay, the charges is moving. Okay, when there is an electrical energy is available when the charges is moving. Okay, never mind. I think this topic we need to do many experiment, many activity, but never mind lah. I just had to ni lah, just to explain it to you only lah ya. Okay, never mind. I just want you to observe the video first, yeah. Sorry. Okay, can you see the video? I hope you can see the video lah. Yeah. It's not the video lah.
Good.
Okay, never mind. I just explain it to you later. I will give you the video now, yeah. Never mind. Okay. Okay, class, like this. Oh, that's so slow. Okay. Electrostatic charges, you just remember, electrostatic charges is available in all type of surface, including at your hand. Okay, there is an electrostatic charges everywhere. Sorry. There is an electrostatic charges everywhere, including at any surface, especially in your hand, any object. Okay, and then electrostatic charges come in two type of charge. Okay, if you the word charges here meaning that it has two type of charge. Number one is positive, and then number one is negative charge. Okay, one is positive, one is negative charge. Okay, and then when there is what we call equal number of charges on the surface, we call it neutral. Okay, if there has an equal charges, for example, this one, the object have equal charge, equal positive and negative charges. Okay, if you can see in the picture here, right? The negative, how many negative charges? This is just example only, because the amount of charges is too many. Okay, this is just to show you only, right? Okay, it will call neutral charges. The object is neutral of any charges if it has an equal amount of negative and positive charges here. Okay, where does the charges come from? Okay, the charges come from naturally. Okay, Right now, for example, at the surface of your hand, your hair, your clothes especially, there is a charges. And these charges occurring naturally. Okay, it's occur naturally. Okay, there is charges anywhere. Can you understand me, class? There is electrostatic charges anywhere, everywhere. Okay, but the charges is what we call static. Static means it doesn't move. All right, and then usually the amount of charges, for example, in our hand or in my hand here, is equal. Right? So if it equal, meaning that we have neutral charges here. Okay, we have it doesn't have any charges. We call it neutral. Yeah? Why? Because positive charges and negative charges same amount. Okay, this is what we call the charges. Okay, so if the surface, right? For example, the picture on your left over here, if the surface, right, consists of many positive charges. For example, here, how many charges? How many positive charges on the object on the left? We have 1, 2, 3, 4, 5. We have 5 positive charges, for example. And then the negative charges, just 2 charges. Okay, and then in this type we can call that the object is what is the name of the object? What is the condition of the charges? We call it positively charged. Okay, positively charged. If the amount of positive charges is more than, negative charges, right? So we call the object positively charged. Okay. Next one on the picture on your right are the negative charges. Negative charges is more than positive charges. We have 1, 2, 3, 4, 5, 6, 7. For example, we have 7 negative charge, whereas positive charge we only have 1, 2, 3, 4, 5. Only 5 charge of positive charge. So we can say that the object is negatively charged. Okay, if equal amount, we call it neutral. Okay, the problem is now why some object is positively charged, why some object is negatively charged, and then why some object is neutral. All right, where the others object go? Okay, so you must remember the charges, right? The charges on the object can be jumped or can be transferred to one surface to other surface. Okay, can you understand this? All right. It is not all the way equal amount. Okay, sometimes the charges can be jumped from one object to another object. Can you understand me? Sometime, yeah. For example, here, this is neutral object, and then sometime the negative object will try to jump to another object. If there is what, class? If there is what? If there is what we call friction. Okay. If there is a friction, then what we call the charges will able to jump or transfer from one object to another object. Okay, this is what we call by electrostatic charges. And then you must also remember, if same charges, okay, it will repel each other, and then if it's the opposite charges, it will attract each other. The what we call the attraction or the properties of electric charges, same charges repel, and then different charges will attract to each other. Okay, very difficult for me to explain without activity actually. Okay, never mind. How to do it? Okay, again, what makes the charges jump from one object to other object? Because there is what is the word I just said just now? If
Friction.
there is a what? Friction, right? If there is a friction, or when two different type of object will rub together, okay? Two different type of object rub together very vigorously. When you what we call rub the two object together, there is a friction. Okay, when there is a friction, the charges will transfer from one object to another object. Okay, one of the object will become negatively charged and one of the object will be positively charged. Okay. Okay, you try to understand. You try to read the article, the notes first, before we continue. Okay, example here. We have two type of object over here, right, class? We have two object, right? Number one is what object, class? Object number one is, what is the object number one? What is this object? This is the
Woolen cloth.
woolen cloth. Yes, very good. Thank you. This is woolen cloth. The first object is woolen cloth, and then the second object here is, we call it plastic comb. Okay, one is plastic comb, one is woolen cloth. One is woolen cloth. One is plastic comb, one is woolen cloth. So it has different material lah, different material. One made from plastic, and then the second one here made from wool, cotton wool. Okay, so we have different type of material. Okay, before rubbing, before we rub the woolen cloth with the plastic comb, okay, what is what we call the charges on woolen cloth and the charges on the neutral on the plastic comb? Anybody? What are the charges before we rub the woolen cloth with the plastic? Okay, first, before we rub, the picture on the left, the picture on the left. Okay, we do it together. Okay, at woolen cloth, before we rub the plastic comb, what do you think the amount of charges here? Is it positively charged? Is it negatively charged, or is it neutral for both woolen cloth and plastic?
Neutral.
Okay, number one, very good. Number one, what we call the charge is neutral. Number one, the charge is neutral. If I can draw the picture over here, neutral. Neutral mean what, class? Neutral mean? Neutral mean what?
Same positive and negative.
Yes, it has same positive and negative what? Negative charges. For example, like this line, I just draw it to you. Right? Same. This is also, we call it neutral. Okay, this is neutral. N-E-U-T-R-A-L, neutral. Okay, how about the plastic comb before we rub it? Also what? Also neutral. Woolen cloth neutral, and then the plastic comb also neutral. Neutral comb, because if you count the number of positive and negative charge, same amount. 1, 2, 3, positive, positive charge, 1, 2, 3, 4, 5, 6, 7. And then negative, 1, 2, 3, 4, 5, 6, 7. Same amount of neutral. Same amount of charges. Before, you must remember this. This is what we call before being rubbed. Okay, and then what happened to the pieces of paper in at the bottom here? This is the pieces of paper. Also what? Neutral, positively charged, or negatively charged paper over here. Number three over here, down there. The paper here, negative, positive, or neutral? Yeah. Plus paper, pieces of paper down there. Positive, negative, or neutral? Yeah. How to determine the charges of the object? Huh? You just count the what? You just look at the diagram there. You just count the number of positive and negative charges. Okay. So how many negative? 1, 2, 3, 4, 5, 6. How many positive? 1, 2, 3, 4, 5, 6 also. So this is also what class? This is also neutral. Yeah. 3 object neutral. Right? Before being rubbed. Woolen cloth neutral, neutral comb also neutral, and then the pieces the pieces of paper also neutral. What's meaning by neutral? Same number or equal number of positive and negative charges. Okay, can you understand this?
Yes.
Boleh faham? Okay. Yang lain tolong ya. We have many days to go. Alright. Okay, so this is before. Then after you rub it with woolen cloth, what will happen? Can you see the difference? Okay, we take a look at A first. We look here first. This is A lah. A, and then B, and then C here. Okay, what happened, you think? After we rub it very vigorously, woolen cloth, we rub it with the plastic comb, what will happen? What will happen, class? You look at the number of charges in plastic comb first. What is the number of the charges on the plastic comb? Okay, negative how many?
10.
Negative we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, we have 10 negative. And then positive?
7.
7.
Right. Okay, very good. Thank you. Positive, we have 7. So the comb become positive charge or negative charge object? The plastic
Negative.
comb. It will become negatively charged object. The question is, where is the other 7, 8, 9, 10? Where is the other 3 positive charge from the plastic comb? Where is the other 3 positive charge from the comb after being rubbed with the woolen cloth? Go where?
The wooden cloth.
Very good. You can understand it very good. It goes to the woolen cloth. Okay, after it being rubbed. Okay, after it's being rubbed. So before we have 3, if you look at my drawing there, before we have 3 positive, but now we have add another 3 lah, for example. This one how many? Sorry. This one's 1, 2, 3, 4, 5, 6, 7. Never mind. Okay. And then the negative, same amount. Negative, same amount. Okay. Meaning that when you rub the plastic comb with the woolen cloth, the positive charge will jump to the woolen cloth. The positive charge here jump to the woolen cloth. Okay. So the woolen cloth will be positively charged, and then the plastic comb become negative or positively charged? Class? Wooden cloth become what? After we rub it?
Positive charge.
Yes. Not wooden, sorry. Plastic comb will become negatively charged, and then the woolen cloth will become positively charged because the charges, the positive charge on the plastic comb jump or transfer from the plastic to the woolen cloth. Why? Why the charges jump? Why the charges jump or why the charges transfer? Why? Because there is what? What's the word? Because there is what, class?
Gravitational.
Gravitational, not gravitational, because there is friction. Can you remember? Because there is a friction when you rub very vigorously. Kamu gosokkan dia. Kamu gosokkan baju itu, kain itu kamu gosok dengan sikat. Right? When you rub the two objects together, there is a friction. And then when there is a friction, the charges will transfer. Okay, and then in these cases, plastic comb, the negative charges on the plastic comb transfer to the woolen. The positive charges on the plastic comb will jump or will transfer to the woolen cloth. Why? Because friction. If you rub it hard enough, the charges will jump. Okay. Now the woolen cloth become positively charges. The plastic comb become negatively charges. And then what happened to the pieces of paper? What happened to the pieces of paper down here? What happened to the pieces of paper? Okay, the pieces of paper is neutral, positively charged or negatively charged?
Neutral.
Neutral, still neutral, right? Because it doesn't need any friction. Okay, but it will attract to the comb because the pieces of paper will attract to the comb because if you remember the rules, when what we call positive charge, different charges will attract, and then same charges will repel. Okay, because the plastic comb over here try to equal the charges, so the charges on the neutral will try to equalize the charges on the plastic comb. So the pieces of paper attract to the plastic comb until it become balanced again. Okay, can you understand this? Depend on the transfer of the what? Transfer of the charges. Okay, we can do many later on lah. Yeah, we can do the experiment later. Okay, right. I hope you can understand this. But if you have any problem, you can also please ask me. Right? Okay. Any problem? Equal number of proton and electron. Okay, again, proton on your textbook called proton and electron. You just remember proton is positive and electron is negative. That's all. Okay, proton positive, electron negative. Proton positive, electron negative. And then sometimes we'll call it proton, sometimes we call it electron. But you just remember proton positive, electron is negative charges. Yeah. Okay. Electroscope. Okay. Electroscope is just a device. You just remember, just a device to detect electrostatic charges. Device used to check, to detect the electric charges or electrostatic charges. That's all. Okay. Later on, I will show you the video lah later. Okay, and then example of electrostatic in our daily life. And what else? Okay, I think this one, this topic, I think you can try to read for yourself. There are many examples of electrostatic in our daily life. The most common electrostatic that we can hear, we can see, and then we can feel is the occurrence of lightning. Occurrence of lightning. Lightning, class, when is usually the lightning after the rain, when there is a storm, right? You can hear very loud lightning, and then you can see the flashes of the lightning there. Actually, lightning is the what? Lightning is the biggest electrostatic, what we call phenomena that we can see and feel. Usually, we cannot see the electrostatic, because but lightning is the one of the example, the biggest electrostatic. Why? Because if you can see here, the diagram here, okay, Earth is what? Usually the surface of the Earth is positive or negative? Class. Usually, Earth positive or negative?
Positive.
Okay. Usually the Earth is positively, what we call the positively charges. And then how about the upper parts of the cloud? The upper parts of the cloud are usually the upper parts of the cloud is positively charges, and then the bottom part of the cloud is negatively charges. Okay, so the negative charges in the cloud are attracted to the positive charges on the surface of the Earth. Okay, when the proximity or the object, the cloud is near the Earth, all right, the charges from the negative charges from the cloud will jump to the Earth. Because why? Positive, different charges attract or repel. Different charges will attract. Same charges will repel. Okay, because cloud has two charges. Cloud has positive and negative charges, whereas the surface of the Earth will have positive charges. So what happened? The negative charges from the cloud will jump. Remember, will jump to the surface of the Earth. Okay, why the surface of the Earth is not neutral? Any idea? Why do you think the surface of the Earth is not neutral? Why the surface of the Earth is positively charged? Because there is what you think? Because there is what? Maybe because there is a what? What is the how we want to transfer the charges? Because maybe there is a friction, right? The friction between the cloud, the friction between the wind. Wind and object also can cause friction. And then when there is a friction, the charges will transfer. In this case, when lightning, the negative charge on the cloud will jump to the positive charge on the surface of the Earth, so it will produce lightning. And then lightning is a very dangerous electrostatic charge because it contains millions of volts, very powerful, and it can do damage to the building. And then if somebody struck with the lightning, it can, it can what we call kill the person. Okay, if the people struck with the lightning. Okay, Can you understand this? The one of the what we call the phenomena of electro charges in our daily life here, right? Okay. Okay, actually in the lab we have this type of device and we call it Van de Graaff generator. Maybe later when we, I don't know what to say, because you know they said online school until end of the year. But never mind. I will try to do my best lah to show you. Okay, never mind. Okay, any problem? Now is 9:58 in the morning. I think we end the class right now. I will try to what we call show you to make you understand first. If I have any video regarding the topic, because this topic actually need activity in order for you to understand it more. So any question before I stop here? You have any question?
No.
Okay, no question, no problem. Okay, I think I stop here. Stop the class here. See you again next week on Monday. Thank you for your attention and focus. You can leave the class now. Okay, bye-bye.
Thank you, teacher.
Thank you very much. Thank you. Yeah.